Today we will explore a new project, Anti-Theft Smart Flooring System, using dual sensor logic and IoT. Security is one of the most important requirements in today's world. Traditional security systems mainly depend on cameras or single sensors, which often give false alarms. In this project, we have developed a smart flooring-based security system that detects actual human presence using pressure and motion sensing together, and also provides IoT-based monitoring.
The main objectives of our project are 1. To detect actual human presence using dual sensor logic. 2. To divide the floor into multiple zones for location identification. 3. To reduce false triggering using combined FSR and IR sensors. 4. To provide real-time alerts and monitoring using IoT. 5. To add door-level security using a fingerprint sensor. The ESP32 is the central processing unit of the project. It continuously reads inputs from the FSR sensors, IR sensors, and the fingerprint module, processes the dual logic conditions, and controls the output devices like the servo motor, buzzer, and LCD displays. ESP32 also handles Wi-Fi communication, enabling real-time data transfer to the Blink IoT platform. Its multiple ADC pins make it suitable for reading analog sensors like force-sensitive registers, while its high processing speed ensures fast and reliable decision-making. FSR sensors detect pressure applied on the floor. When a person steps on the floor, the resistance of the FSR decreases, resulting in a change in voltage that can be measured by the ESP32 using a voltage divider circuit. In this project, multiple FSRs are arranged in zones to identify which area of the floor is active. FSR sensors help differentiate between actual human footsteps and false triggers caused by air or light movement. IR sensors detect the presence of a person by sensing interruption in infrared light. When a person passes through the IR beam, the sensor output changes state. IR sensors are used along with FSR sensors to form a dual logic detection system. This combination ensures that human presence is confirmed only when both movement IR and pressure FSR are detected, reducing false alarms. The fingerprint sensor captures fingerprint patterns and compares them with stored templates inside the sensor's memory. This module provides biometric security to the system. Only authorized users can unlock the door, making the project suitable for restricted areas such as labs. The 16:2 LCD displays show real-time system information such as zone status, system readiness, and alerts. 2 LCDs are used to improve clarity, one for floor and zone monitoring and another for system messages. This helps users and evaluators easily understand system behavior during demonstrations. The servo motor rotates to predefined angles based on commands from the ESP32. In this project, the servo acts as an electronic door lock. When an authorized fingerprint is detected, the servo rotates to unlock the door. Otherwise, it remains locked, ensuring controlled access. The buzzer produces sound alerts when specific conditions are met. It alerts users during human detection, unauthorized access, or security violations. Continuous or pattern-based beeps indicate movement across different zones, improving situational awareness. Now, let's see how the system works. When we power on the system, the ESP32 microcontroller initializes all sensors including FSR sensors, IR sensors, fingerprint sensor, LCD displays, buzzer and Wi-Fi connection. This floor is divided into 4 pressure zones using FSR sensors. FSRs detect pressure applied by human footsteps, while IR sensors detect movement. When we apply pressure on this zone, the FSR value increases, but human detection will not occur unless an IR sensor also detects movement. Only when both conditions are true, the system confirms human presence. Simultaneously, the Blink IoT app updates the zone status in real time and sends a mobile notification saying human detected on smart flooring. Now I will demonstrate the door security system. When an authorized fingerprint is placed, the system grants access. The servo motor rotates and unlocks the door. The LCD displays access granted. If an unauthorized fingerprint is used, the system immediately triggers an alert, displays unauthorized access, and sends a notification on the Blink app. This ensures high security and prevents intrusions. Using the Blink IoT platform, we can remotely monitor zone status, active, inactive, human detection alerts, door lock status. This makes the system smart, connected, and scalable. FSR is a variable resistor, not a voltage source. ESP32 cannot read resistance directly, it can only read voltage. Therefore, we use a voltage divider circuit to convert change in resistance into change in voltage. Precipitation, very low. ADC value. Floor is idle. No human presence. It shows medium ADC value indicates touch or light pressure, not reliable for human detection. It shows ADC saturates at max, clear human presence, safe because ADC pin never exceeds internal limit. That is all for this project. If you like this project, hit the like button and subscribe the channel.